So in this final video, we'll expand the microgrid with a wind power plant. The combination of conventional power plants with renewable energies to form microgrids is widely spread, and it is considered to be the future of power grids. We will show you how to set up the communication and the electrical connections between both systems to finally synchronize them. The microgrid can also be coupled to the wind power plant with doubly fed induction generator. Start by setting up the communication between the primary system and the wind power plant. On the primary system computer, set the correct IP addresses of the power quality meters using the SCADA's device manager. For this experiment, the SCADA Advanced Remote Control Server and client must be disabled. The SCADA Advanced Remote Control Client of the wind power plant must be enabled, and under its properties, the IP address of the controlling computer of the wind power plant must be selected. After configuring the communication, the electrical connections must also be established. The wiring must be prepared before starting the generators. You can find the wiring diagrams in the respective LabSoft courses. Connect the three phases, the neutral conductor and the protective earth between the generator busbar and the power quality meter of the wind power plant. Both systems are now ready for coupled operation. The primary system must be running before the wind power plant can be started. Start the primary system by clicking on the Run Idle button in the SCADA interface. Wait until the primary generator has reached a steady state. Open the proper LabSoft course in the controlling computer of the wind power plant with a doubly fed induction generator. Now, open the instrument speed control and click on the Enable button to set the machine at 1200 RPM. Proceed to open the instrument synchronizer and activate the Enable button to establish communication with the control unit of the wind turbine. Using the amplitude and frequency buttons, adjust the three-phase voltage to match the voltage set by the primary system. To fulfill further synchronization conditions, both generators must have the same frequency, the same phase angle, and same phase sequence. Once all conditions are met, connect both generators with the line button. Students can also copy the results taken with the instruments directly into the LabSoft course and use them for later evaluation. To facilitate synchronization, the automatic button can also be activated. This option automatically adjusts the proper voltage frequency, phase angle, and sequence, and then the line button can be pressed to synchronize the wind plant with the microgrid. The wind power plant can be controlled using the WindSim software, which includes a SCADA server. This must be configured to establish communication with the primary system. The primary system sets the microgrid frequency and is the principal power supply for the connected loads in island parallel generation. The wind power plant supports the primary system and is regulated in terms of its power output level. This power output depends on the wind profile that can be created using the WindSim software. Once connection between both systems has been started, the load will be shared, depending on the wind profile. Observe in the loggers that the primary system takes over the power supply of the load when there is not enough wind. Alternatively, when the wind is strong, the primary system reduces accordingly its active power supply. Observe that the changes to the wind speed translate to changes in the active power supplied by the wind turbine. The reactive power is supplied by the primary system. This behaviour is clearly seen in the SCADA logger of the primary system. So, many other experiments can be performed using the microgrid system and its extensions that you see here. With this video, we conclude our microgrid series. We hope that you found it interesting, were able to learn something, and even had the chance to get an overview about the experiments and the topics that are covered with this training system. So please don't forget to check out our YouTube channel for further videos on power engineering. Thank you.